All right, we're moving into lesson 10.5. We are working with laws of logarithms. Can you apply the basic properties of logarithms? Now, you've got to remember logs are the same as what we've done with exponents. So, I'm going to take you way over here, and we're going to review what exponents do. Remember, if I am multiplying exponents, when multiplying, I add. When I'm dividing, I am just subtracting. Well, I'll show it like this, 8 minus 5, which is 3. And when I have a power to a power, I multiply. So you've worked with these for a couple of years now. These are the laws of exponents, which you guys know, and you guys are doing awesome with that. So we're going to compare these to the laws of logarithms. All right, so let's look at the laws of logarithms. Notice this is just saying log base b of m times n. What did I do when I multiplied? I added. Log base b of m divided by n. Remember, when we divide, we subtract. And log base b of m to the k, this one's a little different because what I actually am doing is I'm taking that k and I'm throwing it to the front. So notice that k pops right in the front. So we're going to do a couple of these together and we're going to have some fun. This is one of my favorite things to do. If I have log base 10 of a squared times b, times the square root of b, the first thing I have to do is just make that b to the 1/2. Now, let's notice here. Remember, I am multiplying, but we also have a power here and a power here, so we have to actually think of what's happening. So the first thing I'm going to do is I'm going to show when I'm multiplying, I add. So notice we have to write that log base 10 all over again. Log base 10 of a squared plus log base 10 of b to the 1/2. And now remember, when I have that power, we're going to bring it to the front. So here's what my final answer will look like. 2 times log base 10 of a plus, that is a plus sign, plus 1/2 times log base 10 of b. So notice how we have to rewrite that log base 10 each time, and we're just separating it, making it larger using our laws of logarithms. All right, let's look at example 2. It says log base 10 of a to the 5th over the square root of b to the 3rd. So probably the first thing that I would do is I would get rid of this square root of b to the 3rd. So I would rewrite this as log base 10 of a to the 5th over b. Now remember, there's an invisible 2 right here. So this is going to be b to the 3/2. All right. So remember, we are dividing. When we divide, we have to rewrite it as log base 10 of a to the 5th minus, when we're dividing, we're subtracting, log base 10 of b to the 3/2. Now we have to go ahead and take these powers and bring them to the front. So my final answer is, all right, so I have to go ahead and write my final answer. We have 5 times log base 10 of a minus 3/2 times log base 10 of b. So from there, that is called expanding. So these are making them from one log, where we end up actually writing like two logs. Okay, so that's called expanding, and now we're going to go ahead and condense. So let's go ahead and condense. Notice example 3 says 3 log base 6 of m minus log base 6 of n over 2. Well, this one gets a lot of people, and that's why I wanted to go over this. The first thing I know that this is a 3. But what you might not see is this 2 right here is really just a 1/2. So they're taking the whole thing. Yes, on the questions above, we could have written it like that. And remember, we're going to take this 3 and throw it to the exponent, and we're going to take this 1/2 and throw that to the exponent. So my next line would say log base 6 of m to the 3rd minus log base 6 of n to the 1/2. Hopefully from here you know that n to the 1/2 is a square root. Log base 6 of m to the 3rd minus log base 6 of the square root of n. You'll get used to that. That's one that people forget, that this is 1/2 is the square root. All right, moving on. When I subtract, I'm really dividing. So my final answer is just 1 log base 6. I'm going to have m to the 3rd on top and the square root of n on the bottom. And just to answer your question, you can keep the square root of n on the bottom like this. We do not have to rationalize here. All right, we're moving on to example 5 because we are solving logarithms. So remember when we had this same, I'm going to just write a note here, when we had the same base, we could just say, hey, this is equal to this. Well, the same is happening with logarithms now. So the first thing I'm going to do is I'm going to condense the right side. Okay, I know this 3 has to go to the top, and I know when I add, I'm really multiplying. So what this right side is saying is log base 5, and I know this is going to be 2 to the 3rd power. Hey, I know that one. My teacher made me memorize it. Times, well, we already wrote the log base 5, 7. So let's keep going. Let's solve. Log base 5 of x is equal to log base 5. Well, 8 times 7 is 56. So because my log bases are the same, I know that x is equal to 56. So the answer here is x is equal to 56. And let's look at the last one here. We have the same thing in log base 7, and we have a plus sign, which tells me when I add, I'm going to multiply. So my next step will say log base 7 of x plus 1 times x minus 5 equals 1. So remember, I'm going to throw this 1 into the middle, and I'm going to write it as an exponent. So this is really saying 7 to the 1st power is equal to x plus 1 times x minus 5. Oh yeah, we're talking about quadratics here, folks. We do. We have to FOIL. 7 is equal to, first, x squared. Outer is negative 5x, and 1x. Inner is 1x, so that's negative 4x minus 5. All quadratics have to be equal to what? 0. Very good. So we're going to bring that 7 over by subtracting. X squared minus 4x minus 12, because negative 5, if I subtracted the 7 over, is negative 12. And we have to go back again to factor. What are the factors of 12 that add up to be negative 4? X minus 6 and x plus 2. So just like you, I know that the two answers can be 6 and negative 2, but with logarithms, we always have to go back to the beginning and check. So let's go ahead and let's put in that negative 2. Okay, if I put in, I'm sorry, was it a negative 2? Yes, it was negative 2. So let's go back and think about how we're putting in a negative 2 here and a negative 2 here. But let's think about what this is saying. I'm just going to look at this one right here. We know that both are going to be negative. So this is literally saying log base 7 of negative 7 equals 1. So if I was to write this in exponential form, what would give us a negative answer? So anytime you get negatives in these positions, you really have to be careful. And I'm going to let you work on those on your own and try to decide. So when I look down here at our answers, I know that -2, because it's in this answering position right here and right here, which would put it out here. We know exponents can't be negative. They never can be negative. So in this case, -2 is not defined, and therefore it can't be a solution. Could 6 be a solution there? Sure, because 6 plus 1 is 7, 6 minus 5 is 1, so none of those turn to be negative. So the only answer that we have in this case is x equals 6, and that's going to make it a little tricky, but just beware in these positions, log base 7 of, in the of position, you cannot have no negatives. You can't have a negative number. All right, tough stuff, but you guys are smart. I'm proud of you. You guys are doing great.